Question, Alvin selects a tile from a set of tiles as shown. So we have the sunflower. Each of them is one letter. The first card is replaced before a second card is chosen at random. Find the probability that the first card is a vowel. Vowel is A, E, I, O, U. You better write down. Probability, vowel. These are one set. If the first card is U, find the probability that the second card is R.
1/7.
R is 1/7. That is wrong. Say the first card is replace. You already. You must give me back. Then you draw again the second time. So you will always have 8 things to draw. You understand?
Oh my god.
Because of this keyword, you must read this keyword. It's always 8 at the bottom. You take one card, jot it down on a piece of paper, and then you still need to give me back. Still 1/8. Okay, now let's do this question right now. So 2 unbiased dices will roll at the same time. Find the probability that both are 6. Now, this one is S. Okay, it's not 5. 6 with the S. So you write P, both 6.
1 out of 36.
Yeah, correct. 1 out of 36. That's it. So if you never draw this picture, you don't know it's 36 possibilities. Both having the same number. Please here.
1,
Okay.
2, 3, 4, 5, 6. 6 out of 36.
Correct. 6 out of 36. Do not simplify. P both odd. Okay, I also need to count. 1, 1.
Okay.
Oh my god, so many. 2, 1, 3, 1, 5. So 3. Second row not possible. Third row 4, 5, 6. Okay, this row not possible. 7, 8, and 9. Okay, so I think we are looking at the same thing. 9 only out of 36. 6, correct. Without drawing that table, there is no way I can know lah. Example 3, why is the name further probability? Okay, let's read the question. The probability that Anna hits the bullseye on the dartboard is 0.1. Find the probability that she hits the bullseye for the first time on her 4th attempt. Now, I want you to highlight 4th attempt. This is to show that this is the question for further probability. Okay, so you hit the bullseye, the probability is 0.1. Okay, so what is the probability that you miss the center point? Okay, the bullseye is the center point. What is the probability that you miss? 0.9. Yes, good. Because we understand the concept that these two added up will be 1. Okay, now we already know these two probabilities. So when you want to say probability of getting bullseye on the 4th attempt, it means that you are miss on your first, miss on your second, miss on your third, and finally you get your bullseye on the 4th. 0.9 times 0.9 times 0.9, finally times 0.1. 0.0729. Bias means unfair. Person toss a coin for 150 times. I don't know why. It lands on head 51 times. So obviously something is not right. Okay, if hit 51 times, tail how many times? Landed on 99 times tail. So you can see a huge difference, right? It's super unfair. I don't know why it's landing on tail most of the time. Okay, then estimate the probability that the coin lands on the head on the next throw. So at head equal, since this is something that we cannot predict 50-50 anymore, we just follow how many times it happened. 51 times over how many times the person tried. 150. That's it. B, estimate the number of hit that you would expect when this person tried to toss for 650 times. Or probability, which is your estimated one, multiply by the number of things or number of times you want to try. Expected to hit the hit 221 times. Just write TIMES, that's it. A bag contains 3 red balls and 2 yellow balls. A ball is chosen at random from the bag. Its color is noted and it is replaced in the bag. So highlight replace. Changes the whole answer. Remember, replace and no replace is totally different. A second ball is then chosen at random from the bag. Draw a tree diagram to show all the possible outcome. Okay, when you highlight the word replace, it is independent. Replace means independent event. So first step, R, Y. So if there are 3 balls, then you need to branch 3. Now you only have 2 kinds, then you only branch R and Y, red and yellow respectively. So branch immediately. So on top of this branch, you have your probability. So what is the chance of getting red is 3 out of 5. That's why it's written like that. And then you are writing here. Don't write at the top, very confusing. So you write at the bottom, 2 over 5 like that. So that one, you don't have to write choice. You just write first. And then you have another 2 possibility, right? Your second trial can have red or yellow, right? This one branching out to R and Y the second time also. This is a replacement, a kind of question. That means it's independent. How many red balls you have in the bag the second time? Your chances of getting red the second time is still going to be 3 over 5. Can you see why is it called independent event? It's the same probability the second time. Okay, so what is your chance of getting yellow the second time? 2 out of 5 lah. Okay, so you just fill up your tree diagram now. 3 out of 5, 2 out of 5. Diagram, we just need to show this. So A done. Let's move on to B. Find the probability that both balls are red. So B1. Red. Take 3 over 5 times 3 over 5. So it's 9 over 25. 2, B2. P, yellow. 2 over 5 times 2 over 5. Okay, you can look at your diagram. So you get yellow, 2 over 5. You go to the right of the branch, is multiply. Okay, when you go towards right hand side of the diagram, is multiply. Okay, just now was red, right? Go right, you go right, then you take the numbers and multiply. Okay, that's how we use the tree diagram. This is the tricky question here. Let's try this. Different colored are chosen. The question asks for different colored being chosen. So the first possibility is red and then choose yellow, isn't it? Second possibility is the person choose yellow first and then red. So you must include both scenario. The red, yellow. Because I know enough space, right? So I write the capital letter and then yellow, red. So you must account all possibilities. So you have to add up. Okay, let's do our working. Red is 3 over 5. Multiply with 2 over 5. Put a bracket so that you don't confuse. This is one possibility. Plus, put a bracket again. This is 2 over 5 times 3 over 5. Okay? 0.48. 12 over 25. And I will use another method to do part 3. Part 3 got also another method. You can use 1 minus red, yellow, isn't it? So what was P red just now? 9 over 25. What was P yellow just now? 4 over 25. Let's try. 9 over 25 minus 4 over 25. Okay, type this in calculator for me. This is also for part 3. Okay, it's 12 over 25, right? See? Okay, so sometimes There are many ways to do probability. Draw how many times? Two times. Okay, okay. 1, 2. Blue or yellow? Okay. Blue, yellow, blue. 4/6. So this one must be 2/6. Look at the way I do tree diagram, right? You see? When I do 4/6, immediately I must check is 2/6. And then I will do a mental calculation to make sure these two add up to 1. I will drop 1 already, because I only have 3. And I did not replace. They already highlighted for us. So it's 5 only. Then this must be 2/5 because I know these two add up must be 1. Okay, so I'm ready. Let's do our answer of 12/30. Confirm, Okay, so your question is blue. 4/6 times 3/5. Correct. Let me write down your answer first. 2/30. They want yellow. 2/6 times 1/5. Correct. Easy. Over 15. Oh, it must be using calculator because this is simplified. Okay, so two different color. I presume you use this again. Your answer from A and B. I'm going to use calculator also. 12/30 minus 2/8/15. Correct. Okay, I will do 1 minus blue. Can or not? If I do 1 minus blue, it means that I'm considering blue, yellow, blue, and yellow. You see, that's why I'm asking you, you do 3 things or you do 1 thing like me. Okay. Minus, do I have the blue answer? 12/30. So I'm going to check your answer now. Indeed, 18/30. See or not? Your past year paper 4 is like this. Something like this, paper 4. In the survey, 100 adults are asked whether they like coffee or whether they like tea. Okay, so there are 2 kinds of person. Now, if you don't like tea, you go outside lah, 16. Okay, so I hope you remember what does it mean if you're outside of the circle. This one doesn't like coffee or tea. This one likes both coffee and tea. All right, so make sure that all these numbers add up to 100. Very important skill. I just sit there and understand. Okay, a person is chosen at random. Okay, I teach you the trick. When you do set and Venn diagram probability, right, highlight the first sentence. This one, you highlight the whole thing. You must find out how many person they try to get the answer from. So from A, right, a person chosen at random means the whole class. The whole 100 people are being targeted from this. Okay? So find the probability that the person does not like coffee. Now, looking at the sets and Venn diagram, how many people don't like coffee? That means 25 plus 16. Okay, so 25 plus 16, that is going to be 41. So how to show your working? Oh my God, not like coffee. I have to write lah, okay? Not like coffee, 41/100. Remember to choose the outside person also because they don't like coffee as well. B, again, the trick is to highlight the first sentence. A person who likes tea is chosen at random. So now it's a different category. Not everyone is being interviewed right now. Not 100 people anymore. It's only those people who like tea. I interview them. Okay, I question them using a microphone. So let's look at how many people are interviewed. In the tea category, how many people are interviewed? Yeah, 71 only. This one I never interview because I asked the tea people only. So this one cannot count. This one cannot count. All right. So 71 people are interviewed. Find the probability that this person also likes coffee. So I am looking at 46/71. Yeah, 46/71. So they try to trick the student in terms of the bottom number. I'm no longer asking everyone. I'm asking the person who likes tea only. So that's why I want to highlight. C. 2 person are chosen at random. Now I need to choose 2 person. Find the probability that they both like coffee. Highlight the first sentence again. Out of everybody, that means over 100 again. You understand this logic? Now
Yes.
I'm asking 100 people again, but 2 of them will be chosen, okay? So I am going to do the working now. Now, probability that they both like coffee means probability coffee times probability coffee. Now, what is the chance of me getting someone who likes coffee? How many people are coffee addicts? Yep, 59. 59 over 100 first. Now, after I interviewed and I chose one person, so let's say that person is Nivita. Okay?
Okay.
So I already chosen Nivita from the group. How many person left?
58 over 99.
Yes, exactly. 58 over 99 because I already identified Nivita from the group. So I only have 58 coffee lovers over 99 people left to be interviewed. Because you use calculator, it doesn't matter. If you want to simplify, I say no problem. 4950. Hey, if you really like the video, don't forget to like and subscribe to the channel for more mathematics tips and tricks. I'll see you in the next one. Bye bye.